heterozygosity of a p53 in the patient. And so if you look at EGFR mutation, all the tumors, either the adenocarcinoma or small cell lung cancer, all have EGFR L858R mutation, meaning that the adenocarcinoma and the small cell lung cancer all derived from the same clone initially. However, when the adenocarcinoma becomes resistant, it actually gained the EGFR T790M mutation, but such mutation was not present in the small cell lung cancer. Instead, the small cell lung cancer had the PIK3CA mutations, which was not present in the resistant adenocarcinoma, meaning that these two tumors diverge at a certain stage and then gain the separate mutations that become resistant to the treatment. So here it's demonstrated that p53 is lost in the small cell lung cancer derived from the lung adenocarcinoma. So how about the RB? As we learned from the previous slide that RB is also commonly lost in the small cell lung cancer. So here in the table 1, it actually showed a number of the patients, the genomic and profiling data, and it's probably too busy for you to really look through right now. But I would just like to summarize that in the patient who initially had a lung adenocarcinoma but developed a small cell lung cancer, as specified here as a neuroendocrine tumor, and there's a loss of RB in all the cases. All right, and RB was a still intact in the tumors that remains to be adenocarcinoma, either prior or after the treatment. So again, this proves that the T53 and RB are important in the small cell lung cancer carcinogenesis. All right, so now actually we are in the genomic era of cancers. So there have been a number of large studies to look at the genomic abnormalities of the small cell lung cancer. And actually, one reason to do such kind of analysis is try to find whether there's any actionable mutations in the small cell lung cancer that can be treated with, either the target therapy or other kind of small molecule inhibitors. So here I only include the data from one of the largest studies, which was published in 2015 Nature. And this study sequenced the small cell lung cancer from over 150 patients, and the data actually is summarized here. So the first thing you notice is that on the top of this panel show that p53 and RB1 are the most commonly mutated genes in small cell lung cancer, so which is consistent with the previous slide. So the mutation of these two genes are present in over 95% and 85% of the patients. The second group of genes that's worth mentioning is the ET300 and also CREGDT. These two genes are histone acetyltransferase, and those genes are involved in the gene transcription. And the third class of genes that are commonly mutated in small cell lung cancer are the Notch family genes, such as Notch1, 2, 4. On the right-hand side, actually show what genes are commonly deleted or amplified in the small cell lung cancer. The blue color represents genes that are commonly deleted in the small cell lung cancer, such as p53 and RB, CEDKN2A is a p16, and FHIT is a gene that's located in the chromosomal 3T. I mentioned that chromosomal 3T is also commonly deleted in the lung cancer. So on the right-hand side, it shows that the NEC family genes are commonly amplified in small cell lung cancer, and the fibroblast growth factor receptor 1 and the RS2, which play a role in the PI3 kinase signaling, are commonly amplified. All right. So here, the author summarized the pathways that are currently affected in the small cell lung cancer. So let's look at the top left panel, which actually shows that p53 and RB1, both of them are important checkpoints of the cell cycle, are commonly mutated in the small cell lung cancer. So in real cases that does not have the RB1 mutation, it was found that the cyclin D1 is amplified due to the chromosomal rearrangement, so that it can bypass the RB1. The right panel has shown that some of the oncogenes are very rarely mutated in the small cell lung cancer, such as the PIK3CA and the KIT oncogene, as well as fibroblast growth factor receptor 1. So I mentioned earlier that the two histone acetyltransferase are commonly mutated in small cell lung cancer, but their roles are still not very clear. MYC genes is commonly amplified. So here in the lower right panel actually show that the Notch family genes are commonly mutated in the small cell lung cancer. Notch signaling actually is very important in controlling the neuroendocrine differentiation by affecting the expression of ASCL1, as shown here. So ASCL1 is a master transcriptional factor for the neuroendocrine differentiation, and the Notch signaling actually can suppress the expression of ASCL1. So in the small cell lung cancer, when Notch receptor is mutated, it actually decreases the Notch signaling so that SDL1 can be upregulated. That leads to the neuroendocrine differentiation in small cell lung cancer. All right, so I want to just talk a little bit more about the Notch signaling. And this is a cartoon shows the signaling cascade of the Notch pathway. So the Notch receptors are membrane receptors. So when there's a proper ligand, and the Notch receptor will change its configuration so that it exposes its susceptible sites to the gamma secretase. So gamma secretase will cleave the Notch receptor so that the intracellular domain of the Notch receptor can serve as a signaling molecule and migrate into the nucleus. So once the Notch intracellular domain get into the nucleus, it actually can bind to the complex formed by the phosphamine-like protein, as abbreviated as MAMA1 here, as well as its partner RDPJ. And I would like to think that the Notch intracellular domain serves as a key, so then it inserts into the lock formed by the MAMA1 and RDPJ, and then activates the downstream gene transcription, such as HAS and K gene expression. Okay, so to explore the role of the Notch signaling in the small cell lung cancer, actually the author of the Nature paper established a transgenic mice that can overexpress the Notch2 intracellular domain. So that the Notch signaling can be constitutively turned on in these transgenic mice. So here show the formation of small cell lung cancer in the transgenic mouse model with 3 genes knockout, including T53, RB1, and RB-like1. And here show the transgenic mice with the forced expression of Notch2 intracellular domain. As you can see from here is that there's a decreased number of small cell lung cancer in the lungs of these transgenic mice when the Notch2 ICD is overexpressed. And here shows the quantitative data that the number of the tumors as well as the volume of the tumors got decreased. And on the right-hand side shows the survival curve of these transgenic mice. And the forced expression of the Notch2 intracellular domain actually extends the survival of these transgenic mice. So again, it supports that the inactivation of Notch signaling plays a very important role in the pathogenesis of the small cell lung cancer. All right, so next I'm just going to give you a few examples of the successful translational medicine in the small cell lung cancer. So first I will talk about RoboT. So again, it's related to the Notch signaling. So let's kind of go back and look at these signaling cascades. So there's a number of the ligands that can bind to the Notch receptor, and one of the ligands is DLL3, which is actually a ligand that can inactivate the Notch signaling. So a group of scientists from the Scancentrics, a company based in Southern California, actually made a finding, an independent finding, a number of years ago that the DLL3, which is an antagonizing ligand of the Notch signaling, is overexpressed in the small cell lung cancer. So here shows the expression of DLL3 based on the RNA-seq data. So the y-axis shows our RPKN number, and so as you can see from here that the small cell lung cancer has a much higher expression of DLL3, about 40 to 50-fold higher than the normal lung tissue. And here shows the small cell lung cancer cell line, which also has pretty high expression of DLL3. So I just want to stop here for a little bit, so that if you have such kind of finding, so how would you translate into patient care? So actually, the scientists from the Scancentrics kind of developed a new strategy to target the DLL3 on the small cell lung cancer cells. So they actually developed an antibody drug conjugate. So here shows the structure of this antibody drug conjugate, and this is something they call RoboT. So this is formed by an antibody that can recognize DLL3 on the surface of the small cell lung cancer. And this antibody is actually conjugated to a linker with the very toxic chemo agent called PBD. The PBD can bind to the smaller groove of the DNA, so-called the DNA damage. But PBD itself is very toxic, so you cannot give it to the patient directly. So what happens is that once you put the PBD as a payload to the antibody, and then it can become a very target agent that can deliver the PBD specifically to the cancer cells that express DLL3. So here shows the experiment data of the efficacy of RoboT in a patient-derived xenograft mouse model. Let me just help you to go through this. So first they established the PDX model of the small cell lung cancer. Then they treated the mice with the EP. So here's C stands for cisplatin and E stands for etoposide. So EP chemotherapy. So there's a shrinkage of the tumor volume. But what happens afterwards is that the tumor recurs very fast. Sorry, let's go back. And then if you don't give any treatment, as depicted as a black curve, the tumor will just grow continuously. And here, they actually, for some of the mice, they actually give the DLL3 antibody drug conjugate, and the tumor size shrinks again. But equally, the effect lasted for a very long time, so much better than the chemotherapy agents. So here in the panel I, they also kind of tested the rechallenging of the mice with the chemo agent. Again, those CS mice were treated with the chemotherapy first, and then when they had a recurrence, these mice were treated with the ET chemo agent again, as is shown here. So this time, the response lasted even shorter compared to the first time, and those tumors are growing back, as depicted as the blue curve here. So at least around the PDX mouse model, it showed that the DLL3 antibody drug conjugate seems to be more effective than rechallenging these CS mice with the chemo agent, again, when the tumor had a recurrence. All right, so with that data, then they moved this drug into the clinical trial. And this is the results from the phase 1 trial reported by Charles Rudin from the Memorial Sloan Kettering in 2016 ASCO meeting. So in this phase 1 trial, they included 74 small cell lung cancer patients who had a recurrence after at least one line of chemotherapy. So some patients had sensitive disease, and some had a resistant and refractory disease. So the definition of the sensitive, resistant, and refractory disease are explained here. So basically, if a patient does not have a progressive disease after 3 months after the first line chemotherapy, then it's considered as a sensitive disease. So meaning the disease is sensitive to the chemotherapy, and the effect is durable more than 3 months. So if a patient had a recurrence or progressive disease within the 3 months after chemotherapy, then it's considered as a resistant disease. So if a patient cannot have any response but continue to have a progressive disease, meaning that tumor continues to grow even when the patient is receiving chemotherapy, it's considered as a refractory disease. So we just want to kind of point out here that about 57% of patients have more than 50% of tumor cells with a DLL3 expression, meaning that if the target is highly expressed in the small cell lung cancer patients. Here is the objective response rate of the LOMA-T in this phase 1 clinical trial. So as shown here is an objective response rate that includes the completed response, meaning there's no more tumor, plus the partial response, meaning that tumor decreased size by more than 30%. So if you don't select any biomarker, in all the patients, no matter whether the patient expresses DLL3 or not, you have 18% of patients who had a response. When you select for the patient who has more than 50% tumor cells expressing the DLL3, the response rate improved to 39%. And on the right-hand side, actually shows the clinical benefit rate, which includes the patient who had a response and the patient who had a stable disease after the treatment. So again, it shows that when you select for the biomarker, the response rate got much better. And this is one part of the response, the potential response after treatment. And here they actually stratify patients based on the expression level of the DLL3. So all these patients had a shrinkage of the tumor, but the patient under the dotted line is considered to have a response after treatment. As you can see here, that most of the patients who had a response had an expression of the DLL3 more than 50%, and some of the patients with the gray bar just do not have the data on the DLL3 expression. But again, it makes a lot of sense because this is a target agent, so you need to have a target in order for the drug to take effect. All right, so actually, currently the company has moved forward to the pivotal trial to gain the approval by the FDA for this drug. All right. All right. So now we are also in the immune therapy era. So it's impossible not to mention about immune therapy in the small cell lung cancer. All right. So this is a very famous data that shows the mutation load in the different cancer types. And because of the time limit, so I just want to point out that, so as it's shown by the arrow here, the small cell lung cancer also has a very high mutation load compared to other tumor types. So what's the significance? So although we don't really know exactly what's the relationship between the mutation load and the response to immune therapy, but it appears that if a patient's tumor has more mutation, so that generates more new antigens that can be recognized by the immune system in the body, so that the patient may have the T lymphocytes that can recognize the tumor cells. So although the body may have the T cells that can recognize the tumor, but that doesn't mean that the immune system is turned on to eliminate the tumors. That's because the body has the different immune checkpoints that helps to inhibit the immune response. That actually is used as a protective mechanism to protect the body parts from being attacked by the immune system. However, the tumor cells can take advantage of that. So there's the two immune checkpoints that can be targeted by the approved FDA drug. One is the CTLA-4 that can be targeted by ipilimumab, and the other one is the PD-1 and PD-L1 system. So that can be targeted by the PD-L1 or PD-1 antibody. So how about expression of PD-1 or PD-L1 in the small cell lung cancer? So as shown here, that the PD-1 or PD-L1 positive cells are present in the stromal cells instead of inside of the small cell lung cancer tumors. But these, when this paper was published in 2015, there's a letter to the editors submitted later, which actually showed that if you use a different antibody, some of the small cell lung cancer can also have a positive staining of the PD-1 or PD-L1. So this is the summary of that study. And basically, as I mentioned, they did not find any PD-1 or PD-L1 positive cells in the tumor, but they found positive cells in the stroma. So it raises up, kind of a question. If you give a patient just a PD-L1, whether that will be effective enough to activate the immune system, because it seems like the immune cells are like out of the periphery of the tumor, but not really inside the tumor. So there's kind of leads to this idea to combine the anti-PD-L1 with the CTLA-4 antibody. So this is a CheckMate 032 study, and so here they actually tried three different arms. The first arm is just anti-PD-1 itself, that's nivolumab, and the second and third arms are the combination of anti-PD-L1 with the CTLA-4 antibody at a different dosing frequency. So the middle one is the nivo1 plus the NP3, and the last one is the nivo3 plus the NP1. So this is the patient characteristics. So I just want to point out that if you look at the PD-L1 expression level, most of the patients have a very little expression of PD-L1. And so here is the response data. So if in the arm with just the nivo alone, there's about the 10% of response rate. And when you combine nivo with ipilimumab, so there's the response rate gets double. And on the right-hand side, which are the spider plots, which show how each patient responded to the therapy. So the only thing that I wanted to bring you to attention is that there's a long tail, which show that the tumors can be put in check by the therapy for a very long period of time. And the therapy itself is not benign, so some patients also have very severe autoimmune disease after treatment. So there's a number of other promising agents that are under clinical development, such as a V1 inhibitor. A 20% of objective response rate was reported in a very small phase 1 trial. PARP inhibitor is also promising, and so 10% of the partial response was reported in a phase 1 trial. And importantly, SLOCK11 is identified as a potential predictive biomarker of the PARP1 inhibitor in small cell. And Aurora kinase A is also promising, and 21% of partial response rate was reported in a multi-center phase 2 trial. So I just want to mention that Dr. Beverly Teicher at an NCI graduate, and her group did a large study. She actually screened over 64 small cell lung cancer cell lines, and over 100 FDA-approved oncological drugs, as well as over 400 investigational drugs, and look to see what drug is effective in the small cell lung cancer. And this is a paper that you can look. So the typical response is that some tumors are sensitive, some are resistant, and this is to be the common theme in all these drugs. And this is a website that you can look at their data, because it has the gene expression data of over 64 cell lines, and also included the IC50 values of over 500 compounds. So it can be a great resource if you are interested in the small cell lung cancer research. Because of time limit, I will skip this. So just to summarize, small cell lung cancer is a recalcitrant cancer, and new therapy is urgently needed. And P53 and RT1 are commonly lost in the small cell lung cancer. And the newer therapies, such as antibody drug conjugate and also immune therapies, are coming. All right, thank you so much. And if you have any questions, I will be happy to proceed.
Do you think there's subtypes of small cell lung cancer?
Yes, I think so. Yes. So actually, in the Beverly Teicher study, she actually tried to group a small cell lung cancer based on the microRNA expression, and that seems to be, and the expression of certain microRNA may correlate with sensitivity to a particular type of a drug. So that seems to be